Es un honor tener a Raphael Mechoulam, catedrático de Química Médica en la Universidad Hebrea de Jerusalén y pionero en el campo de investigación en cannabis y el sistema endocannabinoide. Entre sus numerosos hitos, investigadores incluyen el aislamiento y caracterización del THC y de la anandamida. Muchas gracias.
And this is many thanks for inviting me. It's a pleasure, it's a great pleasure to be in Spain again, to see many of my friends, to hear what they are doing, what they plan to do in many different fields, in cancer, neurological diseases, many other diseases, and I hope that we shall have the opportunity to collaborate, to talk to each other for many years to come. About 100 years ago, the poet Rainer Maria Rilke wrote that I live my life in widening circles that reach out across the world and may not complete the last one, but I give myself to it. Well, this is a poetical presentation of what is happening with the cannabinoid field and the endocannabinoid system. It is expanding all the time, and I see at least 3 major phases in cannabinoid research and cannabinoid applications. And I will try to shorten it a bit. The first phase, of course, involves the old history and the original chemical investigations. The old history, in my area of the world, in Assyria, it was used, and many other places as well, in exactly the same areas that is being used today. It was used as the drug that takes away the mind. They called it ganzi gunu. It was used apparently in neurological diseases, and it may have been used in religious rites. Then if we jump ahead 3,000 years, we see that Queen Victoria in England was being imported cannabis from India to treat her migraine. But surprisingly, although morphine had been isolated from opium, the beginning of the 19th century, and cocaine had been isolated from coca leaves in the middle of the 19th century, the chemistry of cannabis was not well known. Now, this is not an academic, purely theoretical thing. As long as the chemistries are known, it's impossible to do pharmacology, it's impossible to do clinical trials, it's impossible to do reasonable clinical applications. So in the many years ago, in the 60s, we tried to see what's in cannabis, and there had been previous work, but because of technical problems, it had never gone ahead. And we found about 10 different compounds which were looked into animals, in mice, and then in monkeys. And we found that only one compound, and I'm giving the structures here, but those of you who have forgotten your chemistry, I hope you'll be able to follow my presentations without the formulas. We found that only one compound out of the 10 compounds that were isolated, or 12 compounds, only one compound affected the monkeys. It caused them to be less active, not very aggressive, and so on. The 2 main compounds were, as you just heard, the THC, tetrahydrocannabinol, and cannabidiol, but only tetrahydrocannabinol caused the psychoactivity, although the cannabidiol seemed to affect a little bit the activity of THC, but it has its own effects. And I will say a few words beginning on cannabidiol. In about 30 years ago, after we had isolated cannabidiol and purified it and approved its structure, we had done, together with many colleagues in Sao Paulo, in Brazil, work on epilepsy. And we saw that in epileptic trials in mice, this compound was very effective. And then after some toxicology, we went ahead and did a double-blind clinical trial. We had about 15 patients. We took 8 patients who were the controls. They didn't get a cannabidiol, they get only the solvent. And the other 8 patients got the material. And out of these 8 patients, 4 had no more seizures. Now, these were patients that were not being helped anymore, adult patients, not children. 4 didn't have any attacks, 3 had very few attacks, and only 1 was not helped. And the controls continued as before. So we published that, and that was 35 years ago. And we thought that, well, now that we have shown that it acts, it will be used. Nothing happened. Nothing was changed in the treatment of epilepsy. Children, and unfortunately there are epileptic children that really suffer and their families suffer, nothing happened. And only in the last 5 years, or 6 or 7 years, people in Colorado, in the US, found that, well, maybe there is something in that paper, maybe cannabidiol is useful, and they rushed into one of the states where it's legal and started giving cannabis with high levels of cannabidiol, and it has been very successful. About 60% of these epileptic children have much less, or sometimes never, have any epileptic attacks. Now in Israel it is an approved drug, and children with epilepsy can get cannabidiol-rich cannabis, and it has been pretty successful, though we have our own problems. Now, this was epilepsy. Again, for 30 years, nothing happened. We could have helped thousands of children. Nothing happened until recently. Well, there is another disease that we have shown recently that cannabidiol helps. And in this case, we also gave pure cannabidiol. And this is graft versus host disease. Many of you know that in certain cancer situations, one has to exchange the bone marrow, either by the bone marrow of a close relative or sometimes from somebody else. And unfortunately, this exchange of bone marrow, which is very important for these cancer patients, is not a pleasant situation because the body attacks the bone marrow. It's an autoimmune disease. The body attacks the new bone marrow, and the bone marrow attacks the body, and the patient is in a very bad shape. Well, together with Dr. Yeshurun in one of the hospitals, we tried giving high levels of cannabidiol because we knew that cannabidiol, from quite a lot of work on mice and some work in humans, we knew that it's an autoimmune drug. It prevents the attack of the body on the new substance which has been given. And we started giving cannabidiol, very high doses, 300 milligrams a day, for a long period of time. And these patients were watched then for many, many months. And we found that, and Dr. Yeshurun found, it's a clinical work, and I'm not a clinician, of course, that in the relatively easy cases, and they're called 2 to 4 grade, we had only 12% of this disease in a really hard form, while in those patients that didn't get it, about 50% had the disease. And in the very serious disease, when even some people could die, and previously it was about 10% of these patients, now it went down to 5%. Well, to the best of my knowledge, nobody is using this in the clinic, although the results were clear. Now it is being investigated in a few hundred patients, and I hope that there will be a paper within the next few months showing that this is a very valuable new drug. Just some work that was done in Germany. We had shown in South America that in one case of schizophrenia, high doses of cannabidiol are helpful. A German group, Leveke, showed that in a double-blind schizophrenia, a double-blind trial, cannabidiol at high doses is just as good as one of the major drugs that is being used. Now, the anti-schizophrenia drugs, many of them are very efficient, they're very good drugs, but most of them cause side effects. In this case, cannabidiol was as good as the anti-schizophrenia drug that was being compared, but it had no side effects. But again, I've never heard of anybody using cannabidiol at high doses as a pure compound to treat schizophrenia, and it's a shame because here we have something that has been shown to be valuable. But not everything comes to the clinic. We have shown in diabetes type 1, cannabidiol is extremely useful. It's an extremely useful drug. Now, diabetes type 1 is a drug in which the body attacks the cells that produce insulin, and a young person, usually it's a young person, has diabetes, and it's a serious disease. Well, we tried that in mice, and there is a group of mice that essentially all of them get diabetes type 1 because of gene changes, and about 100% of them get diabetes, or 80% get diabetes. So we decided, let's look, as we found that cannabidiol is an autoimmune drug, let's start giving cannabidiol when the animals start to get the disease, which is about 11 to 12 weeks over here. Over here at 11, 12 weeks, we started giving them cannabidiol, and only 30% of the animals got the disease, while those that didn't get the disease were right at 80 or 100%. Now, this disease in animals is not different than in humans. It's exactly the same disease, diabetes type 1. But we have been unable to do a clinical trial. There is for many reasons. So we are still trying to work, sometimes without much success. And I hope that it will be cannabidiol, which is an extremely useful drug used in many of these autoimmune diseases. And just to show you that it's real, if one looks at the cells that produce insulin, those cells that are the controls that did not receive cannabidiol, these are the controls, only 8% of these cells, after a certain period of time, were healthy. Those that got cannabidiol, 77% of those cells were healthy. So here we have very strong proof that it works, and it's exactly the same as in humans. How does cannabidiol work? Well, it's a very complicated system, but it seems to be working on the DNA and changing the reaction of the body through a DNA. I'm not going to in that. But maybe cannabidiol mimics an endogenous compound, and maybe we have to find something that cannabidiol mimics its effect. Cannabidiol does not bind to CB1, as you heard, two receptors, does not bind to CB2, but it is a very active compound. Yes, there was a question about synthetic compounds. Yes, in most of the drugs that you buy today are not the natural products on which they are based, but they are derivatives which are more potent or more active. And, for example, you cannot buy insulin, no such thing. Insulin you can buy, but you cannot buy, let's say, a penicillin. There are derivatives which are better. So we have been looking into cannabidiol-type compounds, and we have two types of compounds in which we have put fluorine here and another one, and we have put fluorine over there, here. And these compounds were investigated by a group in South America, and they were found to be 10 times more potent than cannabidiol and have the same non-toxic profile. So I think that in the next 10, 15 years, Possibly we shall have both cannabidiol, cannabis, and we shall have derivatives, and depending on the drug, depending on the disease, we shall have the opportunity to use either this or that. What about THC? Well, as you know, THC has its side effects. As a drug, it is not very useful because it causes the side effects, but it still is being used for several diseases and definitely prevents the side effects of cancer chemotherapy. We did a very large investigation in one of the hospitals, children that were getting cancer chemotherapy. Unfortunately, children also get cancer. We were able to stop completely all the side effects of the cancer chemotherapy. We gave THC 400 times, and a clinician, Dr. Abramov, the clinician who was in charge of this department and did this work, said she has never seen any drug to do that. So THC, not very high doses, given to children that get chemotherapy, most definitely completely stops the vomiting, that completely stops the side effects. It was mentioned about appetite and feeding, and it is also THC, or the cannabinoid system, is involved in the feeding of children to the mother. And we have seen that if we block the system, then the pups of mice, even they are next to the mothers, do not go and do not have the milk they need. We also showed in a clinical trial together with a psychiatrist that in post-trauma, THC given to post-trauma patients, and unfortunately there are a lot of post-trauma patients at different levels of disease. And the post-trauma patients, we had some of them were 2 or 3 were soldiers, 2 or 3 were women that had been raped, and 2 or 3 were in car accidents. And we saw that it was reasonably effective, especially in sleep. Many of these patients do not sleep well. They're afraid to go to sleep. They wake up in the middle of the night with whatever happened to them. We saw that this was very strongly positive, and it was very strongly positive in all those tests that psychiatrists do in the case of PTSD and post-trauma. I hope that it will be used more widely. Unfortunately, again, although it was published, it was a small clinical trial, it has not been repeated, it's not being used. I want to mention the entourage effect, which was briefly mentioned previously. THC alone, people do not like taking it. Most people, all patients, prefer to take cannabis with a high dose of THC or low dose of THC with quite a bit of cannabidiol, but they prefer to take the natural extract or the plant itself, the fruit, not the pure THC. And this is due to something that we call the entourage effect, the effect of quite a lot of compounds that are present in cannabis, terpenes, maybe flavonoids, that change to a certain extent the effect of THC and make it more reliable for use. And if those of you who have used cannabis know that it is better, much pleasanter, if you wish, to take the flower or the extract, but not the pure THC. Marinol, which is pure THC, has not been a major drug. It's a minor drug. And the reason is that it does not contain the entourage compounds. Unfortunately, we still don't know what the entourage actually means. What are the compounds there that change the activity or modify the activity of THC, but it's there. It has been shown many, many times, and this is one of the areas where in the future a lot of research is going to be done. Well, as I said, there are 3 phases of cannabinoids. The first was what I talked until now, the plant cannabinoids. The second phase was where we, over 20 years, since the 60s when we looked into chemistry, until the 80s very little was known about the mechanism. We knew how it works, the pharmacology and so on, but we knew very little about the mechanism. And in the 80s, based on reports by many groups, Alan Howlett in the US was able to show that there is a receptor, and you heard about the receptor. There are now 2 known receptors. And receptors don't exist in our brain because there is a plant out there. Receptors exist in our body because we form compounds that activate them when needed. This is part of our mechanism of regulating our body reactions. So we went ahead looking for these compounds, and based on what Alan Howlett had shown, that they are present in exactly those places in the brain which are affected by THC, places called basal ganglion, cerebellum, and hippocampus. We looked at the brain of pigs to see whether we can isolate a compound which mimics THC, and it is very complicated. It involves a lot of work. You take a cannabinoid, in this case a synthetic cannabinoid, very, very potent. We bind to it a radioactive substance, and you take this compound and bind it to the receptor, and you see whether something that is formed in the brain can replace it. It's an equilibrium, can replace it, then we look for it. We worked very hard for several years, and we ultimately found 2 compounds. One of them we called anandamide, the second we called 2-AG, and this was published in 1992, almost 30 years after we had seen the THC in the plant. Now, those of you who remember your chemistry will see that these compounds are completely different than THC. THC is the compound on the top, the anandamide and the 2-AG, the 2 compounds on the bottom, completely different. Apparently, they form something which is not so different, and they bind to the receptor, and they're more or less acting like THC. So THC, as was said before, mimics the activity of these 2 compounds. Now, you can see we discovered them in 1992 and later 1995, the second compound. So it's a long time. These compounds have been tested very widely in animals. There are thousands of papers on anandamide and a little bit less, but still thousands of papers on 2-AG. Yet these compounds have never been given to a human, never. Now, this is unbelievable. When insulin was discovered in the 20s, and it was known to be good for certain diseases, it was within 6 months it became a drug. Here we have 2 active compounds, which are known not to be toxic, which are known to have positive effects, and yet they have never been given to a human anywhere. Now, this is a shame, but administration, that's the way it works. Governments don't do that kind of work. Companies are not interested because they're natural products with no patents. So here we have something that may be of major importance in the clinic, yet it has never been tested. Well, nevertheless, there is a huge amount of interest in these compounds. The major journal, one of the major journals in the world, Nature, had 3 or 4 reviews recently on cannabinoids, and they put it on the front page. This is, as you can see, they draw a brain with cannabis growing out of the brain. Well, the reason for all this interest is because the endocannabinoid system is of extreme importance. As a matter of fact, researchers at NIH have written down, have published, and this is based on scientific evidence, that the endocannabinoid system, the endocannabinoid activity, may have therapeutic potential in almost all diseases affecting humans, and they give a long list with a lot of references. Now, there is no other system that we can say this about. I mean, there is no other system in which we can say in almost all diseases affecting humans. There are many reasons for that. One of the reasons is that the endocannabinoid system regulates many of the other systems. It has activities of its own, and it also regulates many of the other diseases. So we should be very careful. We should examine it in great detail, and that's why there have been thousands and thousands of papers on anandamide and 2-AG, the two compounds I showed you before, on the endocannabinoid system. So I will say a few words about it. I wouldn't go into great detail. Of course, there are the receptors. There are the two endogenous compounds, anandamide and 2-AG. There are the enzymes that produce these compounds. And by playing with these enzymes, maybe we can get somewhere. There is a THC and cannabidiol. And there are also some compounds I'll be saying at the end of my lecture. Whoop. And what do these compounds do? What does the endocannabinoid system do? This is a list that I made some years ago. If I could, I probably can have 3 or more slides. These compounds, or this system works starting from anxiety, blood pressure, digestive system, etc., down to movement, pain, stress. So we are dealing with something that has a lot of effects. And another reason for the many effects it has, it because it regulates the other compounds. The nerve system is not a string that goes from one place to the brain. It is the nerve system. The nerves break down at certain points, and these points are called the synapse. And this is done so that the body will have a better regulation. So the nerve signal comes down the nerve, stops at the synapse, goes from one part of the synapse to another by chemicals, neurochemicals, and then goes on through various systems. The cannabinoid system is one that regulates the passage from the presynapse, the coming in part of the synapse, to the second part. So here we have something of extreme importance, and that's why the cannabinoids of one of the reasons why the cannabinoids have such importance. Well, I'll just mention give a few examples. The cannabinoid system, as I mentioned before, essentially all the activity of THC, which I mentioned before, are due to the CB1. The CB2 receptor is, from a therapeutic point of view, probably more interesting because it does not cause activation of the CB2 receptor, does not cause the psychoactivity. It has essentially is of protective nature. It is essentially a therapeutic agency of the body itself. And possibly it works together with the immune system. The immune system which we have tries to block amongst many other things that it does, tries to block the microbes that attack our body. Within the body, the immune system is also active, but here also the CB2 system is extremely active. So they seem to act together. And a few examples. Traumatic brain injury. Some years ago, with one of our colleagues, we looked at what happens to brain trauma in mice. And we saw that the 2-AG, one of the neurotransmitters, goes up nearly 10 times. Here, after 4 hours after the trauma, the 2-AG has gone up nearly 10 times. Is this because the brain has been traumatized and doesn't know what it does, or is it a reaction? Well, we synthesized 2-AG and gave the poor animal with the trauma, and we saw that it was much, much better when it was given 2-AG. So the endocannabinoid system blocks the effect, to a certain extent, of the brain trauma. And indeed, if we gave the mice, we gave the brains, we gave the brains of the mice to the physicians that work on these things, and they saw that those animals that were the controls, there was twice as much damage, and the white matter here is the damage, than those mice that got the 2-AG. So this endocannabinoid system works in brain trauma, and we, as I told you before, seems to work in humans as well. And so there has been a lot of work on the CB2. Because of lack of time, I'll just move to the third stage of cannabinoid research, which is a stage at the present. Many people are working on this third stage, which is still not well understood. And these are endocannabinoid-like compounds which we produce. How did it come out? Well, when we looked at what I told you before, the brain injury, 2-AG seems to work on these compounds which are present in the brain, in the body, glutamate, cytokines, and so on, and ultimately, if not well regulated, they can cause cell death. But it seems that 2-AG does not work during brain trauma and vasoconstriction. When there is brain trauma, the blood vessels constrict, and 2-AG didn't seem to be all that active there. Is it possible that something else was also involved? So we looked at whether something else is acting under vasoconstriction, under one of the major damages during brain trauma. And we saw that, yes, there is something else. Now, our body is lazy. If it can refrain from doing things, it will do so. We have seen this in a group of compounds called steroids. This is a steroid. Once the body knows how to make a compound, in this case a steroid, it will do everything possible around it in order to save energy, not to do too many things. And indeed, in our body, there are androgens and estrogens and steroids and compounds of different types which are made by the body, different compounds with different activities, because it's lazy. It tries to take something it knows how to do and then make small modifications. So why not with the cannabinoid system? We know that anandamide is made by the body, and anandamide, which is made from a compound called phosphatidylethanolamine, is always together with something very closely related called phosphatidylserine. So we thought, well, maybe the additional activity which we saw that is not done by the endogenous compound that we know is made by something else, by a derivative of anandamide. And we looked into there, we synthesized, we worked very hard, and indeed we found a compound which is being investigated very thoroughly, arachidonylserine, which is closely related to anandamide. And yes, it works in many respects like anandamide, but it doesn't bind to the receptor. So we said, okay, maybe we have many additional compounds, and we looked at the activities of these compounds, and although they don't bind to the receptor, their activity can be blocked by receptor antagonists. So things are becoming very complicated. We don't know what's going on, but we know that these compounds are active in neuroprotection. These compounds, for example, if you act under brain trauma, they act, although they do not bind to the receptor, they act like the endogenous cannabinoids. And so we have here what I said, the third phase of cannabinoid research, compounds which are very closely related to anandamide, the THC-like compound in the brain, very closely related, but they do not bind to the receptor, yet they do more or less many of the things that are being done by the endogenous cannabinoids, and they seem to be somehow involved because we can affect their activity by antagonists. Becoming very complicated, but that's what we have. And I will end by mentioning something in the same area of research. We have been doing something which we thought is completely unrelated to cannabinoids. My lab works in different areas. We had read and learned that people in the Mediterranean region have less osteoporosis than people in, let's say, Norway. And the reason they thought was because of olive oil. So we said, okay, let's look at olive oil and see whether it affects osteoporosis, bone disease. Now, essentially all women have osteoporosis after the age of 50, with the change of the hormonal changes, but no, not all of them have serious osteoporosis. Some of them have more, some of them have less, and of course, men have osteoporosis. So we looked at what's going on. Is indeed olive oil active? We looked at the activity of olive oil, of oleic acid, which is the main constituent. It didn't work. We decided, well, maybe it's a metabolite. Maybe the oleic acid in the body is converted into something. So we looked there, and we found a compound which is closely related to anandamide, closely related to many of the other compounds found there, and it is a derivative of oleic acid. Oleic acid is a derivative of this compound, and we found that in bone, oleil serine helps osteoporosis. So it involved quite a lot of work, but we found that this compound blocks the activity of the enzymes that break down the bone and enhances the activity of those enzymes that build the bone. So it is very active probably in humans as well. So we took female mice, took out the hormonal system, and after a certain period of time, they developed osteoporosis. See, this is the bone going down from the green to the red. And at this point, after 42 days, we started giving them the oleil serine, and their bones started forming again. Here we have another compound which is anandamide related. This is the third phase, which is not very clear what's going on. But here we have a third compound that acts like anandamide. But it does not act on those things that we knew before. It acts on the bones. So we seem to have a whole group of compounds, there are several hundred of compounds of this type, which are anandamide-like, and they act on a huge number of diseases and they act as regulators of our body. So many people are working on this third phase of cannabinoids, and I will repeat, the first phase was the plant and the compounds in the plant. The second phase was the anandamide, the endogenous compounds that we have seen that bind to the receptor. And now we are, and many other groups are working there, we are in the third phase with a lot of compounds present in our body which act in different ways, not necessarily by binding to the cannabinoid receptor, but in other ways. So chances are that within a few years we shall have many drugs, cannabinoid-like drugs, if you wish to call them, and these compounds will be of extreme importance, and maybe, just maybe, they also have to do with our personality. There are so many compounds, they act on the central nervous system. Maybe they have something to do with our normal being, namely the different personalities. There are a few hundred people here, all of us are different, and the reason for that we don't know, but maybe this is one of the genetic reasons why we are different. There are so many anandamide-type compounds, and the differences between them, if you have 200 compounds, there are many differences possible, they determine parts of our personality. So I think I will stop there. Just mention one thing that came out 3 days ago. One of these endogenous-like compounds was shown by two groups that it helps with wound healing. Out of the blue, nobody thought it's in that direction. So we have all the times new things, particularly in this third stage. And to summarize, the endocannabinoids are involved in a large number of physiological processes, and THC mimics their activity. The CBD may lead to novel drugs, and it seems to work through the changes in the DNA. The fatty acids, the third stage of which I was talking now, may lead to novel drugs, and the CB2 is a protective system of major interest. So I've touched many problems of the cannabinoid system, and so you can see how complicated it is, but I believe that within the next few years, we shall have major advances, and I would like to thank my many collaborators in Israel. I would like to thank many of my collaborators abroad. My group collaborates with many groups all over. They come over to our place, I come over to their place. I've been in all these places many times, except this one in Siberia. There was a meeting, a cannabinoid meeting in Siberia for February, and I asked Dr. Maslov, and what is the temperature in Siberia, in Tomsk? He said, no, this year it's okay. Usually it's minus 35, now it's only minus 25. So I said, thank you, and I thank you.
Bueno, felicidades por su intervención, por su ponencia, y mi pregunta va dirigida a el comentario que ha hecho sobre el efecto positivo del cannabis en la esquizofrenia, que es verdad. Y les explicaba que en la clínica muchos pacientes esquizofrénicos, psicóticos, no solamente esquizofrénicos, con otro tipo de psicosis, usando el cannabis se estabilizan. Pero también sabemos que hay gente que brota precisamente al consumir el cannabis. Normalmente es cierto que va acompañado de mezclas, consumo de otras sustancias, pero esto nos lleva a que nadie se atreve a sugerir para nada el consumo del cannabis. ¿Podría explicar un poquito más por qué se sabe que es tan eficaz, pero al mismo tiempo hay brotes psicóticos?
No.
¿No?
No. Here, can I answer now?
Yes.
Well, cannabis itself, the THC and CBD, should not be used in schizophrenia. THC, in some cases, can cause an effect in schizophrenic patients. What I mentioned is pure cannabidiol. Pure cannabidiol has been shown to be valuable and effective in schizophrenia, but not THC. So giving an extract of cannabis, which is THC and cannabidiol, should not be done. Only pure cannabidiol.
Siguiente pregunta, por favor.
Gracias.
Hola, buenos días. Gracias por su exposición. Yo me voy a centrar un poquito más en las razones por las cuales, si es bien sabido desde hace muchísimos años que en farmacología, que algunos de los efectos secundarios de medicamentos contra el dolor que se están empleando hoy en día, si es bien sabido que esos efectos secundarios son indeseables y a veces son inaguantables para los pacientes, ¿por qué hay esa resistencia tan fuerte todavía a hacer investigación, a hacer ensayos clínicos, a aceptar que esos efectos secundarios de fármacos que ya están en el mercado pueden ser tan o peores, tan grandes o peores o más fuertes o más inaguantables que los efectos secundarios que eventualmente puedan tener cannabinoides utilizados en terapia? O sea, ¿por qué hay esta resistencia todavía que parece casi inhumana contra algunos pacientes?
Well, it's not a psychologist, and I can't say anything about the psychology of governments. In all countries, cannabis is still an illegal drug, including Holland. It is an illegal drug, and there is a problem of how, when to use it, and every country has a different mechanism of taking care of that. So it's becoming very complicated. Besides, it is not only not well regulated, but usually people say, I am taking medical cannabis without knowing exactly what they're taking. Now, when you go to a physician and take a drug, any drug, he will not just tell you take antibiotics, bye-bye. He will tell you take exactly the 300 milligrams of an antibiotic, use it 3 times a day, and come back in a week. With cannabis, we have not reached that situation. And so if somebody uses medical cannabis, it can be anything. So here we have a situation that has to be improved. A person that's getting medical cannabis should know exactly what he's getting and should be able to repeat every time, if he's being helped, the material that he's gaining, that he's getting. So here we have a situation that's not well regulated, and until it is well regulated, there will be problems. Now, we are trying in Israel to regulate it. We just passed government regulations that every single cannabis, medical cannabis, should be, there should be an indication of the levels at least of CBD and THC for the moment, maybe possibly later other compounds. And a person should be able to know what he's getting, and there are different levels. There is a material with high CBD, low THC, material with high THC and low CBD, and 50-50, as well as pure cannabidiol. Now there have been regulations that will come into effect within a few months, I hope, so people will be able to do that. So it is not, medical cannabis is not yet well regulated in most countries, and I believe that is still not well regulated in Spain as well. And until it is well regulated, like all other drugs, there will be problems. It has to be well regulated. People should know what they're getting. And just to give you an example, there was a mother that came to me. Her child had epilepsy, and she was getting a bottle with that helped her with cannabis extract. And then when she finished that bottle, she went and bought a second bottle, and the kid started getting epileptic attacks. So I analyzed the 2 bottles. One of them had a lot of CBD, the other had very low levels of CBD. Now, that's not a way to treat anybody. It should be well regulated with exact amounts. So that's the reason why we are one of the reasons why we are in a problematic state.
Quisiera agradecerle la charla y su excelente carrera científica. Mi pregunta está orientada al tratamiento del THC con el PTSD. Como puede saber, hay compañeros suyos de la Fundación MAS, liderada por Rick Doblin, haciendo estudios en dicha enfermedad con otra sustancia, el MDMA. Y mi pregunta es si podría haber algún tipo de sinergia en este tipo de estudios entre las dos sustancias, entre el THC y la metildemetoxianfetamina.
Yeah, I don't believe that there have been any clinical trials on this aspect, and so it is very difficult. There have been very few well-regulated clinical trials, so I cannot comment. I don't know because there is no literature, there is no medical literature on the topic. One of the problems, we have very, very few clinical trials. In cancer, for example, there have been thousands of patients that are using medical cannabis of one type or another. There is a lot of work on cancer, much of it coming from Spain, but we don't have a single published a clinical trial with medical cannabis and and cancer is not one disease, there are many diseases, so we need a lot of clinical trials. There isn't a single one at the moment, so major one. So we have a problem, a major, major problem in cancer, for example. I know that it acts, but how much, when, what kind of cancer? Is glioma and pancreatic cancer and prostate cancer the same? Obviously not, and so we don't know. I wish I could say, yes, use so much and so on. I wish I could.
Última pregunta, por favor. Hugo.
La primera es, habló del efecto Entourage y todavía no hay efectivamente clinical trials sobre eso a fondo, pero mucha gente opina que los terpenoides y los flavonoides influyen en ese efecto Entourage. ¿Y cuál es su opinión, aunque no haya estudios científicos sobre ellos? Y luego, si diera tiempo, me gustaría preguntar sobre qué opina de los extractos de CBD que vienen del cáñamo. Gracias.
Well, the entourage effect, this is a term that we published about 10 years ago. As I said, there are no clinical trials. What I meant at that time is that we can take one, either cannabinoid or a terpene or a flavonoid, together with THC and compare its activity to pure THC. We know that it is different. We know that from the reaction of the people that use cannabis. People that use cannabis say, all of them essentially, the mixture is better than the pure THC. And, but what is in the mixture? What are the terpenes that are being involved? We know that there are many different types of terpenes, there are different types of flavonoids. We should have more basic data there, and we don't. So at the moment, we can just say, the way it was done in the 19th century, if you wish, the mixture is better than the pure compound in this case. It's not satisfactory, but there we are. And that was the second question?
About the CBD, about the CBD made with hemp instead of cannabis.
Well, if we're dealing with pure CBD, and here apparently pure CBD can be used as a pure compound without the entourage, that's what it seems to be possible. There should be no difference if the CBD is exactly the same in the hemp, exactly the same as in other cannabis. It may be exactly the same if synthesized. As a chemist, a compound is a compound as long as it answers the questions of physical data, whether it's the molecular weight and breaking down in mass spectra. Whether these compounds are exactly the same, there should be no difference. But at the moment, cannabidiol is essentially not available, either as a synthetic compound, as a pure natural product. It's also essentially not available, which is a shame.
Muy bien, gracias.
Thank you.